You want me to move?
Hi, everyone. My name is Reuven. I'm an engineer at Google. This is my colleague Marwa from product management. And we're here to talk to you today about big data analysis and how to make it fast. So, those of you who've done this before, who've written big data analyses before, know how painful it can be sometimes. You spend a lot of time writing your configuration files, managing how much parallelism you need, managing pools of machines. You often spend more time doing this than you actually spend writing the code that does your analysis. We want you to be able to move very, very quickly from concept, from sort of your whiteboard design of what you want your analysis to be, to production code that runs and runs at scale. These pipelines also need to be really fast. The world we live in is very, very quickly changing, and you need to keep up with real-time trends in your data. Your pipeline needs to be able to stream in current data and constantly update its results as the data comes in. So, to allow you to solve these problems, I'm really excited to give a peek at Google Cloud Dataflow. Those of you who were at the keynote yesterday and actually stayed there till the end of the keynote already got a peek of Dataflow in action. So what is Dataflow? Dataflow is a system for building big and fast data analysis pipelines. The way it works is you write a sequence of logical data transformations that are easy to write and very intuitive that specify the analysis you want to do. You submit this to the Dataflow service, and it runs for you. It's fully managed, so it runs for you on as many machines as are necessary in order to run your pipeline. All the configuration, all the parallelism, all of the tuning, it's all taken care of for you. And you don't need to spend a lot of time thinking about that when you're writing your program. So let's look at a quick example that uses Dataflow. So a feature that you're familiar with from many websites out there is auto-completing words. So for instance, Google does this. As you start typing a search, we auto-complete and give search suggestions. And also Twitter does this. If you start typing in a hashtag, Twitter will automatically start suggesting hashtags that you might actually be trying to type. So what does it take to build an application like this? And let's focus now on this Twitter example of auto-completing hashtags. Well, there's a front end that displays this. And the front end is all about displaying it well, and intuitively and making it easy for the user to use. But the front end needs a back end to serve up the data, to tell the front end, OK, the user has typed in AR. What are the suggestions that I should display right now for AR? And this is something that's been traditionally painful, building these data models and keeping them up to date. And this is particularly what Dataflow makes easy to do. So for this auto-completing of hashtags, let's start off by thinking about what we would need. So what we need to do this is a prefix model. What the users are typing are prefixes of hashtags that they want. Until they've typed the entire hashtag, you have increasing prefixes. So we want something like this. Actually, unfortunately, the slides seem to have scrolled off the screen a little bit. I'm not sure why. But what's missing here is on the left side here, I'm putting AR, ARG, ARGE, and we're showing that the suggestions are for these prefixes. And you see as the user types in more and more characters, we've colored the prefix that they've typed. The the suggestions keep refining. So this is the model we want to build. This is the data we want for our application. Let's think for a minute how we would go about logically building this model. I'm going to start off with a batch analysis over a bunch of static data. For instance, all the tweets that happened yesterday. Then later I'll show how we will modify this to process streaming data to keep up with changing hashtags as they start and stop trending. So I know where I'm starting from. I know where I'm going to. I'm starting from this big batch of tweets that happened yesterday. And at the end, I want to produce predictions that I can write out somewhere where my app can read it. So we want to start off by reading these tweets. So let's read. So we read it, a whole bunch of tweets. You know, Argentina scores, Armenia versus Argentina, which is not a real game, by the way, my art project. And for reference, I put down the models that I actually want to write out here. So I know where I'm going to as I'm building up my pipeline. So I want these prefix models. I want models that map every prefix to a list of suggestions. So I'm trying to autocomplete hashtags. So I actually don't care about anything in the tweet that's not a hashtag. So let's extract the hashtags. And now I have Argentina, Armenia, Argentina, and so on. Next step is I know that I'm going to need to rank these hashtags to decide which are the most popular ones. So let's count them. So I'm counting how often every unique hashtag happened yesterday. And in this fake data set up here, Argentina happened 5 million times yesterday, Armenia 2 million times, and so on. Now, looking back here at my results I want to get, I'm reminded that I want prefixes of all these hashtags. So let's expand all the prefixes. Let's take every one of these hashtags and explode it into all the prefixes of the hashtags. So expand the prefixes. And now this is what we have. I've expanded them into a set of key value pairs, where the keys are all the prefixes of every word that was a hashtag, and the values are the original hashtags that had this prefix. And I'm keeping around this ranking information, these counts, because we're almost here. The only problem is that we have too many results. A is going to have millions of results, and we only want a few results to suggest to the user. So there's only one step left to do to get from here to my actual suggestions, and that's to just take the top 3 results per key using this ranking that I've attached to it from the count. And now I have all the data I need to do this prefix suggestion, this hashtag suggestion. All that's left to do is write it out somewhere and for my application to read that data as the user types it. So we just went through this in the design phase. We wrote a sequence of logical data transformations that made a lot of sense and got us from a batch of tweets to a set of predictions. What does it take to go from this to actual code? And with Dataflow, the answer is not much. This is the actual code I would write in order to run this pipeline. So notice that the lines of code here are matching one-to-one with these logical steps that I wrote here: read, extract tags, count, and so on. So most of my time here was just spent designing. I spent time on the whiteboard or here on the slide designing what the pipeline would look like. And once I was finished with designing, at that point, writing the code was really easy and took very little time. I want to quickly point out these 2 lines here that say pardo, by extract tags and expand prefixes. This is how you insert user-defined code into a Dataflow pipeline. So a pardo, we call it pardo because they are parallel. It's a little bit of code you write that runs in parallel over all the records coming out of the previous stage and transforms them into records for the next stage. Those of you who have used MapReduce before, which is something that we invented at Google about a little over 10 years ago, I believe, might recognize this as very similar to a mapper function, although Dataflow is far more general than just MapReduce. These Pardue functions you write are usually very short, though. So for this expand prefixes, this is the Pardue for expand prefixes. It's a short snippet of code that takes in a word and just iterates over the word and outputs every prefix of the word. So now you have your code here. You can run it locally on your machine with some sample data, iterate on it, debug it, keep going until it appears to do exactly what you want. And then you hit the point where you want to run this on your actual big data at scale. And that's where Dataflow comes in. So you take your code, and now instead of running it locally on your machine, you submit it to the Google Cloud Dataflow service. Once it's submitted to the Google Cloud Dataflow service, it starts running for you and processing all your data. The Dataflow service also gives you a monitoring console, which allows you to monitor this data while it's processing. It lets you see progress of your data and helps you debug problems in your pipeline as they happen. This is a simple and intuitive monitoring console that matches one-to-one to the lines of code you wrote. So we're not giving you these big blocks saying something is wrong in your pipeline. We're giving you, here's what's happening with your extract tags. Here's what's happening with your count. Here's what's happening with your expand prefixes, and so on. So this is all very simple in terms of the use of the pipeline. You don't have to do much to use this service. But behind the scenes, a little more has to happen to make this work. So here's your view. You write your code and submit it to Cloud Dataflow and just watch it via this monitoring console. However, this programming model we gave you allowed you to write very fine-grained steps. You're writing these you extract tags, and then you're counting, and then you're expanding these prefixes. If we actually ran these as written separately on all of Twitter's data from yesterday, this would take way too long to finish. So in order for this to work, we need an optimizer. The optimizer takes in the code you've written, determines which lines of code can actually run together as one group, rearranges things a little bit into something that can run efficiently, and produces this optimized program on the right here to actually execute. Older systems that actually didn't provide an optimizer. So when you use those systems, you usually had to hand optimize your code. So for example, MapReduce again, if you're using MapReduce, you have to spend a lot of time thinking which lines of code should run in the first MapReduce and which lines of code should run in the second MapReduce. We let you just write things logically as they would work in your application, and we do this optimization for you. You need a scheduler. In reality, this is running on a lot of data. This is running on big data. In order to process it, you need many VMs, many machines to process this data. You need to schedule reading stuff in from Google Cloud Storage, distributing the Google Cloud Storage data onto all these worker machines, onto all these VMs, getting data off the VMs and back into your output, which here is also on Google Cloud Storage. You may need to expand. Halfway through the pipeline, you may decide we actually need more machines. We don't have enough. You may need to add some machines to this pool. You need a scheduler to run this, and you don't want to have to configure it yourself. So with Google Cloud Dataflow, we're fully managing this, so all of this lives behind the cloud. You don't have to be aware of all these things that need to happen when you submit your pipeline to be executed. Now, we believe in transparency here, so these worker machines here are Google Compute Engine VMs, so you are free to SSH into them, take a look at your actual code running and see what's happening. But this is never something that you have to do in order to use Dataflow. So we talked about doing this in batch, but we're talking about Twitter hashtags here. Twitter hashtags change very, very quickly. A hashtag that is trending now may no longer be trending in an hour. If we wait until the next day to process yesterday's batch of data to give suggestions, our application is going to be displaying very out-of-date information. We won't be displaying the current trending hashtags. We'll be displaying hashtags that were trending yesterday. We need to actually keep up with the current data. So let's stream it. Let's take this batch pipeline that we just wrote and change it to process streaming data, to process the hashtag information as it's happening. So how do we jump this gap? This sounds like a difficult problem. And in the past, it actually often required rewriting your entire pipeline from scratch using a completely different framework. And with Dataflow, we make this easy, though, and don't require you to rewrite the pipeline. So what needs to change? Let's think about that for a second. Your reads and writes. We were before reading a static set of files containing tweets from Google Cloud Storage. Now, instead, we want to read it from a streaming source providing tweets. So for that, we're using Google Cloud PubSub. Google Cloud PubSub is a new product from Google that just went into limited preview that provides a reliable many-to-many message delivery channel. And here it integrates with Dataflow in order to allow you to constantly stream data in and out of a pipeline. Essentially to create a Dataflow pipeline, a data analysis pipeline that never finishes, an infinite pipeline tracking trends in real time. The other thing we need to do when we write a streaming pipeline that never finishes, is we need to think about the time element. We don't want the tweets that happened last week to still be influencing the suggestions that we're providing. So we want somehow to age out the old data and prioritize the new data that's coming in. So continuing my example of the fake Argentina-Armenia game, here's a graph of suggestions that may begin with AR. As you see, for a while, a lot of people are searching for Argyle, and over time, that doesn't change. But as this game begins and ends, the data of people tweeting about Argentina and Armenia in the game starts trending, and after the game ends, excited and disappointed fans start tweeting. And then eventually, over time, as the game fades into the past and people forget about it, we would expect this graph to start converging back to something looking like the beginning. So what do we want to do to modify our pipeline to keep track of what's going on now? So we're going to use a sliding window. So if we take a window of time that keeps advancing as time advances, we want our pipeline to track data within this window and immediately forget about data before the window, so we're prioritizing the stuff that's happening now. So what does it take to go from this to actual code, to change my pipeline to be a proper streaming pipeline? Again, with Dataflow, very, very little. So here is the pipeline we wrote earlier, the batch pipeline for tweet analysis. And let's change this to be a streaming pipeline. So first of all, our core logic that's doing our actual analysis doesn't have to change. Extracting hashtags, counting, expanding prefixes, there's nothing streaming or batch specific about that. So let's leave that alone. We no longer want to read data from Google Cloud Storage. We want to instead read data from PubSub, from our streaming source. So let's change that. Now we're reading and writing data from PubSub. How do we add this sliding window to age out old data? Well, it takes a whole extra line of code to do that with Dataflow. And there we go. we add a bucket by sliding windows of 60 minutes. And now our entire pipeline is processing on the last window. And data older than this window is aged out. Dataflow provides far more sophisticated buckets than this as well. Although these buckets, the sliding window bucket is often sufficient for most needs. Changing the code here was very, very simple. We did very little to go from batch to streaming. But behind the scenes, again, a lot more has to happen. So this is our behind the scenes picture again. But now it's been modified to show what's happening for a streaming pipeline. Our optimizer has to change. The optimization algorithms for optimizing a streaming pipeline are different than the optimization algorithms for optimizing a batch pipeline. Scheduling is also slightly different between streaming and batch. Instead of managing a bunch of static files in Google Cloud Storage, we now have to manage pub/sub topics and subscriptions. Our worker VMs need a little bit of storage in order to keep track of this bucketing data to see what data it's seen so far. However, again, the point of Dataflow is even though many things have to change in the backend to go from batch to streaming, you are insulated from this. You use a programming model that's focused on the what you want to do to the data and not as focused on the how you want to do it to your data, which means that changing this how, changing the batch analysis to a streaming analysis is simple and you don't have to write a completely different program. So let's take a quick look at what this actual running pipeline is. This is this monitoring UI that I hinted out earlier, and this is this actual pipeline running right now. So as I scroll through it, you'll see that all of these boxes correspond exactly to the code I write. I have a bucket by, and extract tags, a count. If you look for a second, you'll see that extract tags, the data coming out of count is lower data rate than coming out of extract tags because it's coalescing all unique tags. But then after we go out of expand prefixes, the data blows up to from 1,200 to about 11,000 because we're taking every word and fanning it out to all of its prefixes. This is also a place where I would look for problems in my pipeline. So if there was a problem, if the data out of expand prefixes dropped to 0, I would know that there was a problem in expand prefixes, and I should go and look at that part of my code. I can also hover over these edges here, and I can see that this edge between into extract tags, here's the total records we've seen so far, and it's currently lagging about between 4 and 7 seconds behind real time. So here we have a really quick App Engine app I threw together that is listening to the pub/sub output stream of this Dataflow pipeline and using it to give suggestions. So I had it pre-filled with B. Right now, there's a game going on between Germany and the US, so I'm going to type in GERM and see what we get. And here we go, Germany for World Cup, Germany versus USA. If we kept watching this long enough, we would see these suggestions constantly refresh and change as the Dataflow pipeline keeps giving new suggestions based off of the Twitter input data. So now I'm going to introduce Marwa again, our product manager, who's going to talk to you a little bit more about the Dataflow product and various use cases.
So hello. I hope after all the details we've covered, you would agree that this is a new dawn for analyzing real-time data, especially if it's very large in size, like a stream like Twitter data. And pair that, this seems like something also that's reachable and that you could start using. So to go and summarize the details that you've just seen, which Reuven has just showed you, we have two very important things that we need to remember. The first one is that solving a problem uses a logical sequence of thinking, and that writing code should follow that without having to compromise efficiency. You shouldn't have to twist how you think in order to write code that is efficient. You can write the code the way you think and depend on the system to do the optimization on your behalf. Additionally, when you are writing code for parallel processing, you don't have to take into account the parallel processing aspects themselves. We've seen the custom code. It iterates through a simple data type that you don't have to take into account what is really happening when the parallel processing is taking place. Also, we've seen that model allows you not to worry about deploying a framework, setting it up, optimizing it, fine-tuning it. All of that is inherently taken care of. However, it is not a black box. You can still have full visibility into what is happening within the system. So that was the first point. The second point that we've seen is that your data logic, whether you're running it in batch or streaming, is the same. And switching between batch and streaming should be pretty seamless by just switching the data input and the data sync. And it happens very easily and quickly. And you can do all of that using Google Cloud Dataflow. So when you're starting to build an application or a solution, typically developers have a lot on their mind. They have to worry about the infrastructure where the application will run, what kind of frameworks are included to provide the features and meet the requirements, in addition to the UI and the usability and how to engage the users, a whole lot of things to think about. So what we're seeing today simply allows you not to worry about infrastructure management anymore. You don't have to worry about how parallel processing will happen and how to tune that yourself. You don't have to do that anymore. And additionally, you don't have to go hunting through logs that are distributed all over the place or understand what is happening in the system by purchasing very expensive logging systems. You can simply rely on the monitoring that we provide that allows you to see what is happening in addition to access your logs seamlessly from that one location. And simply just focus on your application, the logic of your application. And now you can easily analyze massive data and include that as part of your application. You can include big data analytics that rely on parallel processing immediately. You don't have to learn new skill sets. You don't have to go and understand how complicated frameworks work. You can start today right away with the skill set that you already have. So let's discuss some examples for that. Log analysis, I hope this is something that is dear and near to everyone. Certainly we can't imagine a world without our logs. So let's imagine that your logs are all over the place and you want to do something like click analysis. You'd start by wanting to read them from everywhere. So if we start applying a Dataflow pipeline, we would start by reading from those different locations just by pointing to them. And then through the pipeline, you would apply the kind of analysis, what kind of information you're looking for, how to understand the user experience as they navigate through the application. And usually people would run this type of analysis every night or every week to optimize the application, to understand how the user experience is working out. But now think that you can easily switch this from taking the log files to inputting this data as a stream. And your application now has an opportunity to not just understand what the user experience is like, but also to react to that user experience. You're able to decide on the fly based on how the user is navigating the application, what is the right thing to show them next, right? Well, the pipeline can also generate information that is usable for reports. So at the end, maybe that information is something you would like to save in a storage of some sort where you can generate reports like BigQuery, for example. Another example is data generated by mobile phones. Today, we all have smartphones and they generate tons of data. Now, you can imagine a pipeline that is reading some information from your mobile phone, something like GPS data, for example. And then using that data, you can generate a traffic model. Using that traffic model, your application can identify where are the areas that people actually pass by most, and from there, where's the best place to open a shop? Also, you can switch this to streaming and apply it to an application that not just allows you to understand where people are going through, when to avoid the most busy roads, but also to think of things like what's happening right now. So if there is a big event, where are people hanging out? Where can I go and join them? And from there, kind of make it more interactive. Another good example is fraud detection. Now, fraud detection is a bit of a more special example because it is dealing with sensitive information. You're dealing with identity, you're dealing with information about financial services, and usually these things people are very careful about. So, in addition to that, fraud detection is something that cannot happen in past tense. You would not be able to be very patient if you know someone already has got your bank account or your identity and are using them. So fraud detection is something that has to be very interactive, and usually the challenge is the amount of data that you have to do in near real-time analysis. But now this is all possible because of technologies like that. We're talking about doing true streaming analysis, not micro batch or being limited by specific amounts of data. You can actually ingest as much data and go to very, very large data as much as you like with this solution. So with that said, if you haven't been thinking about big data before, maybe it's time to think bigger. And it's time to think of the cloud and how it's limitless and makes things a lot easier. And because they are much easier, naturally, it's much faster to develop. And also, you could start dealing with data types you were not naturally using before because of the complexity of the technology, but now it makes things a lot easier for you to be able to include it in your application. And as you've learned throughout I/O from the very start at the keynote, we want to collaborate with you on innovation. So this is really how true progress happens, and we can't wait to see the kind of applications that you will build on top of this. We're really looking forward to that. And speaking of that, I want to point you to a few more locations where you can get more information. We still have events happening in the sandbox area if you haven't visited them already. Also, if you're interested in getting access to these products that we've mentioned, first, Google Cloud Dataflow is in private testing. You can register for announcements, and I recognize that the link is very hard to see. So I'll read it out loud: cloud_dataflow_announce at Google Groups. And this is a link to be able to go to if you would like to apply for the private beta testing. Additionally, PubSub that we've mentioned is already in limited preview, so you should be able to get it off the cloud.google.com/PubSub website. And if you would like to get started with the cloud, there's also a special offer. You could start over there using this promo code, and you would get that much amount of credits to play around, get a feel for these products that are not in limited preview or private beta testing, but play around with the other cloud services that you'd like to get familiar with. With all of that said, I'd like to thank you. We're really happy that you could make it today and join us. And I hope you could see the links better now in this slide. I will leave them up there. And we're very happy to take your questions. Thank you.
Hi, two questions. First, you guys talked a lot about the optimizations you guys do behind the scenes, but then in the visual where you show the flow of data, it seemed to be in the original set of code that the developer would put in.
Yes, and that's actually the point of the visual console there, that even though what we're actually running behind the scenes is not that code as it's written, it's the optimized code, we untangle it for you and let you view it as your code is written.
Okay, and second question, what's the pricing on this?
It's a little bit early because we are in private beta to talk about pricing. Right now, users just joined the private beta, and naturally, that doesn't cost anything at the moment.
Thanks.
You mentioned Google Cloud Storage and PubSub as input readers and writers. I was curious what the others are.
As Marwa said, this is still early, so those are our main input and output sources now, but we plan on supporting more.
Can we write our own?
Yes.
Okay.
Yes.
Can you guys talk a little bit more about PubSub? Should I be thinking about this as sort of a programmable or governed input-output layer that I can just say who can have access to this, who can't, how they can use the data, whether they can read or write it, or is it much simpler than that?
Yes, so you can specify access control on PubSub, and it's a many-to-many. So you configure PubSub topics, and then subscribers can configure subscriptions to subscribe to those topics.
I have a question about your example here. What exactly were you emitting on the output topic or topics?
What I was emitting on that output topic from my example was exactly what I showed in the diagram, a set of key prefix to a list of suggestions. I had it serialized in JSON. So my App Engine app just subscribed to that, listened to all these JSONs and wrote them to App Engine data store. And then as I typed in the App Engine, it just read the suggestions back from data store.
Okay, so you basically cached all the output in data store to be able to fetch it easily from your app.
Yes.
Hey, so I was wondering what kind of delivery guarantees do you have both on the PubSub and actually on the processing pipeline?
So internal to the processing pipeline, we have exactly once guarantees. So all the data internal to PubSub, internal to the pipeline goes through exactly once. If you use PubSub directly, the guarantee you get is at least once. The data will be delivered, but it may try multiple times to get it there.
Okay, thanks.
Do you guys have any numbers that you can share on latency, SLAs, or anything like that for PubSub and for the cloud data flow?
I don't think we have any public numbers yet that we can share on that. Generally, I would expect latency on the order of seconds, but I don't think we have any public SLA numbers yet.
Yeah, not yet.
And then one other question with PubSub. So traditionally, the scaling problem with PubSub is if you have one producer that many consumers are happening, like the Beyonce problem in Twitter. When she tweets, you have to get it to millions of people. Do you have any scale numbers around there, like how many messages can be duplicated to multiple consumers if you're going that way?
So we scale pretty well there, so you can have many millions of subscribers to a single topic, no problem.
Cool.
I had a question. Can we combine the multiple data sources in the data flow, like batch and a stream? Combining batch data source and a stream data source and making one result?
So your question is, can we combine batch and streaming in one pipeline?
Yeah.
And the answer is, it actually depends on the specific problem you're trying to solve, because there are different ways to do that. In general, yes, but it depends on the specific problem, because that can mean different things in different contexts.
Thank you.
Do we have documentation for, say, running this on local right now just to try prototype?
So we don't have any documentation that is public yet. Users who join the private beta are able to see the documentation. We might not have highlighted this in the talk, but the SDK, the Java code that Reuven was showing, runs in two modes. One of them is in local mode, where you're able to execute it on your local machine, pointing to data that's accessible from your local machine. But that's just meant for debugging and development. Another mode is just talking to the service and submitting your workload back into the cloud.
Thank you.
Just in terms of data types, how well does the data pipeline, or rather the data flow, work with spatial information in case we explore on using this for GIS applications?
So we are data type agnostic in the way that you can process spatial information yourself. We don't currently provide any specific libraries for managing spatial information in Dataflow, if that's what you were asking.
Okay, right. Thank you.
It's pretty early as well.
Yeah, this is all pretty early.
Okay, thank you.
I was curious if you had done any large joins with the data in terms of streaming and PubSub and how you manage that?
I'm glad you asked. So we actually we didn't demo it in this pipeline, but we do support joins, both in batch and streaming. In streaming, the joins are often temporal joins. So you want to join based off of some bucketing information. In order to do a join, you essentially need these key value pairs, and you join based off of identical keys on 2 collections, or 2 streams. Any more questions?
Okay.
Well, okay, thank you very much for coming.
Yeah, thank you.